Welcome to the Geometric Proof Part 1 lecturing. Here, the learning target is just for you to get a foundation knowledge of what proofs are. So here, I need you to be able to write statements and converses, and to determine and using properties of equalities. Let's start with the vocab. So every single statement can be defined as having a P, then a Q. So our regular statement is if P, then Q. Symbolize the P, then the arrow means then it becomes the letter Q. The converse is basically the when you flip them. Okay, so if the original was P then Q, the converse would be Q then P. For example, an example that you might have is if your phone is at 0% battery, then your phone is dead. Okay, that would be your statement. So the P would be referred to your phone is at 0%. The Q would be your phone is dead. If you want to write the converse of it, you flip it. So it would be if your phone is dead, that is your new original statement. Then, now this is where you put the Q. Your phone is at 0%. Okay? That's a statement. When you flip, it becomes the converse. Right? Here are examples of how to write a converse statement mathematically. Statement: if two parallel lines are cut by a transversal, comma, then the pair of corresponding angles are congruent. The P is highlighted in red and the Q is in blue. The converse would be flipped. Converse: if the pair of corresponding angles are congruent, then two parallel lines are cut by a transversal. That's it. You're just flipping the P and the Q's. So the vocab and the core concept check. I would like you, the first is to determine the converse. Okay. Then number 2 is for you to write the statement based on that converse. Number 1, the statement is if two angles form a linear pair, then they are supplementary. The converse of that would be if two angles are supplementary, then the two angles form a linear pair. Number 2, the converse is if two lines are cut by transversal, so the corresponding angles are congruent, then the lines are parallel. The original statement would be if two lines are cut by transversal, that was what it was in red, then the two corresponding angles are congruent. Here you go. Some vocabs. In proofs, we use certain properties of equalities. The first one is called the reflex property. This is if you have a number like a equals to a, that's like 4 equals to 4. You could have line segment AB equals to line segment AB. Angle measurement is equal to the same angle measurement. So we call the reflex property the same thing. Symmetrical. If A equals to B, then B equals to A. So let's say X is equal to 4. We can say 4 is equal to X. I essentially just flip it. Likewise, you could see it in the line segment. AB equals to CD. Therefore, you can write CD equals to AB. Or angle A is equal to angle B. Likewise, angle B is equal to angle A. That's the flip. Next, the transitive property. Transitive property is like when you're transferring something. Okay? So if A equals to B, let's say X is equal to let's see, 2 plus 5. Okay, and we know that 2 plus 5 is equal to 7. We know that X is equal to 7. Okay, so we saw that X is equal to 2 plus 5. So this is the original B. Okay, then this is also B. 2 plus 5. A was your X. your C was your 7. So in the end, we could just write A is equal to C, right? A is equal to C, right? That's the transitive property. You're transferring something to something else. That's how it looks like in the line segment world. AB equals to CD, CD equals to EF, right? You can think about the CDs canceling. In the end, you have AB equally to EF. Lastly, you have the angle measurement, same thing. Angle A is equal to angle B is equal to angle C. These two angles cancel out, you get angle A equals to angle C. The thing that the way I think about it, about the transitive property, oh, I wrote this wrong. You are transferring, okay? You're transferring. So A is equal to B is equal to C. You transfer this, right? That's how you think about it. Lastly, you might see substitution. Substitution is a replacement. So here, if you see, if A equals to B, then A can be substituted for B in any case, right? So this is another way of thinking about it. Next, vocab check. I would like you to determine which one of these does not belong. One of them does not belong. Which one is it? Give this a try. Here's the solution. This one does not belong. The statement is based on the transitive property, while the other three are based on the symmetrical property. All of them else flips. Only this one is the one that's considered a transitive property. Next, you're going to name the properties of the equality that the statement illustrates. This is based on the qualities that we just used. Okay? All right. Pause the video and give this a try. Let's go over it. 27. That's the reflexive property because it is the same. If x equals to y, then y equals to x. That flips, so that is called a symmetrical property. Angle z, 29. Angle z is equal to angle z. That is the same, so that's the reflex property. 30. If angle A is equal to 29 and angle B is also equal to 29, we would say angle A is equal to angle B. That's the substitution property, okay? Because the 29 was replaced, so that is considered the substitution property, okay? I will let you get away if you consider that the transitive property as well, all right? 31. If AB equals to LM, then LM is equal to AB. That flips, so that is a symmetrical property. Next, if BC equals to XY and XY equals to 8, we know then BC is equal to 8. That was a transfer, so that is a transitive property. Next, using the properties to copy and complete the statement. So I gave you the name. Now you just have to complete the statement based on the name. Substitution property. You're going to replace, right? Substitute. If A equals to 20, then A plus CD is equal to what? Well, we know that A is going to be replaced by 20. So this becomes 20 plus CD because we replaced AB by 20. Next, symmetrical property. Remember, symmetrical is when we flip it. If angle 1 is equal to angle 2, we flip it. Angle 2 is equal to angle 1. 35. Transitive property. This is the transfer one. Okay? Something gets canceled. If angle 1 is equal to the measurement of angle 2 and angle 2 is equal to the measurement of angle 3, then what? Well, we know that these two will cancel out, right? We know that angle 1 will be equal to angle 3 by the transitive property. 36. The reflex property of inequalities. Reflex property is when it is the same. So angle ABC is equal to the measurement of angle ABC. Those are all the different properties of equalities that you're going to be using. I would like to go over the two types of proof now that you're going to work with. In recent years, proofs you don't have to construct by hand anymore. most of the times you need to be able to understand how the proof works and fill in the missing gaps. So I would like you to take a look. This is a 2-column proof that proves that these two angles are the same, given that they're the same. So given angle 1 is equal to angle 2, you have to prove that angle 2 is equal to angle 1. It's broken down into 2 columns. There's a statement column and there's the reason column. The statements column is based on facts that you know or on conclusion that you can have. Then please understand that the reason here, it gives you the name for it. So here you see how they flipped this. So they went angle 2 becomes angle 1. Remember when we flip things, that was called the symmetrical property. So these are just when you use different postulates, theorems, or anything to prove it. Most of the time you're going to have a gap here and you're going to end up using one of your equalities to prove it. The number of statements will actually vary during the problem. Some are longer, some are shorter. Also remember at the end to give a reason for the last statement that proves it. Okay, this is the definition of congruent angles for this problem. This is considered 2-column proof because there's a statement column and a reason column. This is the same proof but now using something called a flow chart. Rather than give you a statement and a column proof, they're written in a flow chart. So this is the first step, then it flows to the second step, to the third step, then to the fourth step. But they don't label it, but that's how it flows. The arrow shows the flow of things. So it starts with what you're given, like before. You always start with what you're given, and you end with whatever you end with. And it's almost the same number as well. Notice that what goes into the box is the statement and what is in blue is the reason. Okay, notice the first statement is angle 1 is equal to angle 2 and that is given. That is the same way here is given. Second step, measurement of angle 1 is equal to the measurement of angle 2. That's the definition of congruent angles. Notice that is also the same second step. Likewise. So both ways you do the 2-column proof or the flowchart proof, it's going to be the same way. Okay, but there you go. This should give you a basic understanding of geometric proofs.